Yesterday we learned about 3 of our equations. Get your reference packets out, all right, because you're going to need those again today. As I said yesterday, there will be 2 ways that you can solve every problem in this class. What page are we on in the notes? Where did we leave off yesterday? 14. All right.
We finished 13.
Yeah, we're going to be on page 14 here. And we're going to do a few extra example problems that are not right there in your notes, but I'll tell you where they are in a few minutes when we get there. So guys, what we're going to talk about now, yesterday was all dealing with hydrogen. Mostly hydrogen. KW, what is KW again? The what? The something, concentration. Look back in your notes, folks. We wrote it in there. It's the ionization constant of water. So it's related to the concentration of 2 ions. Bless you, the hydrogen ion and the hydroxide ion. All right? And then it's a constant. It's 1 times 10 to the minus 14. Do you have to memorize that number? No, because it's in your reference packet. All right? It's in your reference packet. Really quickly. All right, so we were dealing with KW, guys. Then we went into pH and hydrogen ion concentrations. So that's why I said that yesterday we were really just focused on the hydrogen ion and not really hydroxide. Now, we could go to hydroxide, and we did, using KW. Today, we're going to see those formulas from yesterday and how they relate and how similar they are to hydrogen ion, but it's just using the other ion, the hydroxide. So we know about the pH scale. That's what you guys are more familiar with. You've seen that, probably heard that before this class. You've probably learned about that probably back in middle school. All right. On the pH scale, acids have a what pH? Low pH, right? Lower than what? 7. And bases have a what? A high pH. Now what I'm about to tell you guys is that there's also a pOH scale, where you're looking at the hydroxide ion as the the ion of interest. That scale is flipped. Okay? Bases on the pOH scale have low numbers. Acids have the high numbers. Okay? So you can kind of highlight that in your notes if you want to. Folks, there's no need for you to learn or memorize both, because it's so easy to go between one and the other. If you have pOH and you're asked if it's a base or an acid, convert it to pH super quickly, very easily, and then you know it if you know the pH scale and those acids and bases. Okay? And you'll see what I mean here in just a second. If you want to know the the pOH scale, go for it. It's the opposite. Bases are low on the pOH and acids are high. Folks, here are our last 3 formulas that we're going to look at. 4 and 5 should look very familiar to us. Do they? They look just like 2 and 3 that we learned yesterday. Equation 4 goes right along with equation 2, and equation 5 goes right along with equation 3. The only thing that has changed is what? Right, it's OH. The ion is the only thing that has changed. Which ion you're using is the only thing, but the math is exactly the same. So it's going to be plugging into your calculators. All right, super easy. Now, equation 6, why I have that in green here, I personally don't like to use KW. I do when I need to, and I can, but I would much rather use this formula right here. This formula, guys, is adding and subtracting versus multiplying and dividing. Okay? This allows me to go between pH and pOH very easily. So, this number 14, what does that kind of look like or related to, do you think? 14 on the pH scale, okay, that's part of it.
Constant.
The what constant? KW, right? Guys, take the negative log of 1 times 10 to the minus 14. Do we even need a calculator for that? Why not? And why is it 14, though? Why don't we need a calculator? Because there's what? There's the 1 out here. So because we're base 10, we can just take the exponent and make it a positive. So guys, this is going to be 14. It's related. If you look at pH and pOH with their formulas, look what we did. All we did here was take the log of the hydroxide concentration. If we looked at pH, it's the negative log of the hydrogen. So when we look at this, guys, it's the same as KW, but instead of looking at the concentrations, those big long numbers, we're just looking at the negative logs. So it's much easier numbers, which again is why I like to use this formula when I'm doing my calculations and not KW. Smaller numbers to deal with. And I just have to subtract and add instead of multiply or divide. Right? So as we go through these problems today, you're going to see that there's two methods. Find the way that works for you. If you like KW, use it. If you like pH plus POH, use it. Now, your way that you like may take 3 steps in one problem, or the other way will take 1, but do the 3 steps if you like that better. And I'll show you as we go through and do some examples. All right, so let's take a look here at this flow chart that I just gave you. Now, mine's in color. You guys can highlight it if you want to, make it in color. You can leave it as is. All right. Know how to use it. Color is just kind of showing you one way, kind of like the acid way versus the base way. That's really all it's kind of doing with. But as we go through some practice today, I'm going to show you how to use this. It's going to be a big help for you to start out with, and then you want to wean yourself off of it by Friday because you're not going to have it on your quiz on Friday. Let's jump into an example. We're going to do this example both ways. I want to show you guys both methods so that you can choose which way you like better. All right, I'm going to leave that choice up to you. So it says, what is the hydrogen ion concentration of a solution with a pOH of 8.2? Now, we got to figure out first, how many steps do I need to go through to get to my final answer? So here we go. There's 2 things we got to do. I have pOH. Okay? I have H plus concentration right here. What are the 2 differences with those values? There are 2 differences. By looking at those pieces that you're given, what are the 2 differences between them? One should be pretty obvious.
One's a concentration.
Okay, so one's a concentration and the other one is a what? What does P stand for? Power, right? Power of H, power of OH. So guys, one step is you've got to go from concentration to power. Okay, kind of in quotes there. What's the other more obvious? That was the harder one, I think. What's the more obvious change? Hydroxide and hydrogen, guys. So the 2 steps are, you've got to go from concentration or from power to concentration, and then hydroxide to hydrogen ion. And that's where there's a couple of different ways that you can do that. So let's take a look and use that flowchart that we just had. Where are we starting? On our flowchart, where are we starting? We're starting over here at pOH. Okay, we're starting right here. So there's 2 pathways that we can take. Follow the arrows. So we can follow the blue arrow and go up here to pH, and then from pH to H+. Or we can follow the red arrow. We can go from pOH to OH concentration, and then from OH concentration to H+. And notice with this flowchart, guys, if you follow the arrows, it's showing you what formulas you need to use. That's why this is going to be a huge help for you over the next couple of days while you're practicing. And then eventually you've got to be able to not use this, to just use your formulas in your packet. Okay? So let's kind of walk through this. I'm going to do one way first. Which way do you want to go? Do you want to go from red? All right, I guess we can do red. So red, guys, is going from pOH to OH concentration and then from concentration to concentration. So let's do that first. So I'm starting with my pOH, which equals 8.2. So this method is going to go from power back to concentration, and then once I'm in both concentrations, I'm going to go to my other ion. So if I want to go from pOH to a concentration, what formula will I have to use to get me back to a concentration? What concentration will I go to? Guys, let's think about that. If we look at our flow chart, we're going to go from pOH to what? OH minus. So that's what I'm going to solve for first. That's my step 1. What formula will I use to go from pOH to hydroxide concentration?
pOH equals -1, or no, OH negative.
This is the formula I'm going to use first. So to go from pOH to hydroxide concentration, I've got to use my anti-log of the pOH. Now, folks, yesterday on your calculators, I said to use the caret key. I would recommend doing the second log function. So if we're going to use this formula, here we go. Let's plug it in. 10, what's our pH? I'm sorry, POH? 8.2. So it's 10 to the negative 8.2. When you plug that into your calculator, what do you get? Everybody should be practicing this. If you don't practice this now, don't complain on a quiz when you don't know what to do. Now's the time to ask those questions. 6.3. So based on how you round it, guys, 6 times 10 to the minus 9. Are we done with this problem? No, because our end-all goal is to do what? Hydrogen ion concentration is our end-all goal. So to do that, what formula now will I have to use? So we're now here. We're here on the OH. We've got to go back here. What formula am I going to use? KW. Okay, so here we go. Plug it in. H plus concentration equals 1 times 10 to the minus 14 over the concentration of our hydroxide. So if you were absent yesterday, you're going to want to go back and watch the video from yesterday to see how to use KW if you want to know how to use it. Okay, if that's the method you want to use. I have just rearranged my equation, and I'm just going to plug it in instead of showing all that as additional steps. 6 times 10 to the minus 9. So when I find and I solve for my H plus concentration, do the math. 1.6 times 10 to the minus 6, is that it? M, right? You got to have that unit because this is a concentration. Got to have molarity there. Folks, that's one method. That's one way that you can go through and solve for it. Now we're going to do it the other way, where if we follow over here, we're going to go from POH, we're going to follow the blue method. So we're going to go back to pH first and then H plus concentration. You're going to need to figure out which way you like better and then do it that way every single time. So our starting point's the same and our ending point should be the same. So POH equals 8.2 and I'm still trying to get to my hydrogen ion concentration in the end. Now, if we look at our flow chart, we're starting with POH. We want to go back to pH. Well, what formula? That's that new one. All right, this is the one that I personally like better because I don't have to do any multiplying or dividing with KW. I'm going to say pH plus POH equals 14. Now, if I already have POH and I'm looking for pH, what's my formula really going to be here? pH equals what? Other way around. 14 minus the POH. Because if you did it the other way, guys, if you took your POH and subtracted 14, you're going to get a negative pH. Is that possible? No. It's got to be between 0 and 14. So this is going to be super easy. pH equals 14 minus 8.2. What's our pH? You can do mental math if you want to, but you have a calculator. Use it. What'd you say? 5.8. Does that answer our question, though? No, because we're trying to get hydrogen ion. Now, what we do next, though, is we're going to use our other equation, the last one we haven't used. Okay? We're going to go from pH down to H plus. Well, that's this formula, guys. I believe this was equation 3 that we looked at yesterday. So, it's just plug and chug since we have the pH. H plus concentration equals 10 to the negative pH. Well, when we plug it in, 10 to the negative 5.8, go ahead and do that. And let me know what you get. Joe? Oh my goodness. Look at that. Both ways, different, but where do they end up? They end up in the exact same place. Folks, you have the choice to determine which method you want to use. Whatever way you're more comfortable with. If you're more comfortable using pH plus POH to go between the ions, do it. If you're more comfortable using KW, do it. Whatever way you are most comfortable with, you've got to find that way. Now, what I was saying earlier is one time it may take 3 steps, where the other method will take 1. As you do practice, you'll see that. Okay? But do the way that you're most comfortable with, and do it consistently every single time. Questions on this problem? All right, I want you guys to try this practice problem on your own. This is in the last page of your packet. pOH is what we're looking for. I'm starting here with my hydrogen ion concentration. So what I'm going to do here on the left is I'm going to do the long way. I'm going to use kW. So I've got my hydrogen ion as 2.3 times 10 to the minus 8. First thing I need to do is get to my hydroxide ion concentration so that then I can plug it into my pOH formula. Okay? So that's going to be 1 times 10 to the minus 14 over 2.3 times 10 to the minus 8. That's going to give me my hydroxide concentration. Did anybody do it this way? What did you get for your answer here?
6.4 times, like,
For the hydroxide ion.
I got 4.3 times 10 to the negative
4.3 times 10 to the minus 7 molar. Do we agree with Ray? Anybody else do it this way? Did you get there for that step? Now the next step is you've got to plug it into your pOH. So pOH equals the negative log of the hydroxide ion. So that's going to equal negative log of 4.3 times 10 to the minus 7. When you do that, what do you get for your pOH? Somebody else who did this problem did it this way. What did you get, Lauren? 6.4 is your pOH. All right, that's one way. I'm going to do it the other way now on the right side, starting at the same place. Hydrogen ion concentration equals 2.3 times 10 to the minus 8 molar. All right, and we're trying to get to pOH. So the way I can do it here now is I can get to my pH first. So I can take this value, I can plug it in my pH formula. pH equals negative log of H plus concentration. So when I do that, pH equals the negative log of 2.3 times 10 to the minus 8. When I do that, what do I get for a pH? Who did it this way? They can tell me what they got for their pH. Josh? 7.6. Now the last step is I'm going to solve for pOH. pOH is going to equal 14 minus my pH. So that equals 14 minus 7.6. And what do I get? Oh, look at that. Same answer, both ways. That's it. Looking for hydroxide concentration. We're starting with pH. 3.66 is our pH. So this way we're going to use, on the left I'm going to do kW. So the first step I would need to do is to get H plus concentration. That's 10 to the negative pH, which is 3.66. When I do that, what do I get for my hydrogen ion concentration if anybody did that? Who did it this way? (2.2 times 10 to the minus 4 molar this way. Now you can use kW. So OH minus concentration equals 1 times 10 to the minus 14 over 2.2 times 10 to the minus 4. What do you get then for your hydroxide ion concentration, Briley? Negative 11. That's it? That's it? That's it? Molar. There it is. All right, so concentration, got to have the capital M there. Now, other side, the other method you can use, pH equals 3.66. We're still looking for that hydroxide ion concentration. All right, at the bottom. So this way, though, I'm going to get to my pOH first. So I'm going to take pOH equals 14 minus 3.66. Somebody else tell me, what do you get for a pOH when you subtract those out? Josh? What did you say? Nope, not the final answer. 10.34 is the pOH. Just the pOH, not the final answer yet. Yeah. Now I'm going to come back to here. Hydroxide ion concentration then, folks, is just 10 to the negative pOH. So that's 10 to the negative 10.34. Josh, what do we get here? You don't know? All right, somebody else.
I got the right answer. I know that.
It's the same answer, folks, as the other method. Absolutely.